Hey, going from an email address to a LinkedIn URL can be incredibly valuable. This is a tiny bit of the things I use when I build go-to-market workflows. I will get a little bit into use cases, but like when you think about it, going from somebody's email to somebody's LinkedIn profile, that opens up basically unlimited doors, what you can do with that lead, with that person, with that sign up. And the outcome of what I'm going to show today is how I think about how to attack the problem. There are multiple ways to do this. Understanding how to build it. This is not about giving away a template. This is more like how I think about building this thing. And the end result is actually going to be something that has a 95% resolution from email address to LinkedIn at a cost of maybe about a cent per result. This is how some end result can look like. It's actually quite beautiful to see how many email to LinkedIn resolutions you can come. Of course, it depends a little bit on the market or the segmentation, the segment where the email addresses come from. But following a template will not enable you to adapt for that. When we explore how to think about this, hopefully, this is my goal with this, it could put somebody watching into a position of like, okay, this is how I can really build that whole data pipeline, and I can customize it to the needs of either my company or my client if you're like an agency like I am. What I really want to say, this is not obviously a 3-minute video on LinkedIn of like, click, look how easy everything is, because actually there is a super easy way to do this. It's just expensive. So this is more a learning exercise, an exploration, how to think about this. I'm going to think a lot about the logic that goes into this. I'm going to talk about how to use AI and AI agents, or that's a little bit arrogant, not how to use it, how I use it. And I'm going to talk about the price complexity trade-off that I'm always seeing with these things. And to a certain degree is also price complexity accuracy trade-off. I have to figure out how exactly I think about this. But this is like overall what I'm going to talk about. And then kind of the methods to do even what we want to do here, database lookup versus agents. So here we have it. So there are basically two ways to do this, right? Imagine you get an email, Andreas at Snowball Consult. There are two ways to find the LinkedIn profile to that email, or at least to try to find it. First is a database lookup where you can use Clay and you have Clay look at the email, and then you use a LeadMagic or I believe a People Data Labs or any of the integrations that can take as an input somebody's work email and as an output their LinkedIn URL. They will have done some of what we are doing here on their end and just basically curated the data set. What that means is it's super easy to do. It's literally a few clicks and you have it. The trade-off is that it can be quite expensive. And I'm not saying it's not worth it. I'm just saying this is really pushing it how it can be built. And that also allows for controlling for accuracy and price while adding complexity as well. That might be even a thing that makes this not the right approach, because it's like, I don't know, 30 columns or 20 in order to get to a result versus one column when you do that lookup. That can be a very valuable aspect to consider. But again, this is for learning how to build it. And this is the second part. Use an AI agent, how to build it, or, which is actually how I built it here, a combination of these. Because I am trying, and this is what you can do when you build it yourself, you can balance the benefits and trade-offs you get from these two approaches, database lookup and an AI agent. Okay, let's think a little bit about emails, and I'm going to go into most of this. I'm just going to show how it looks in Clay, and I'm going to go deep into the AI prompts that I'm using, the logic that I'm using. But let's really start with some theory on this, right? So let's look at an email, and I'm always thinking when I use an email, My email is a little bit too long, andreas@snowball-consult.com. That just barely fits on the screen. So I'm thinking Clay can't be angry when I use their email for something. So I'm using Varun. I don't even know if that's his real email address. Varun@clay.com is the real one. Don't send him emails. Or send him emails. I'm sure he's happy. So the thing is, what do you have in an email? What are the challenges? The database lookup is expensive and the agent only is less expensive, but you also might have reliability problems with that. And talking about information density, information in email, you also have to talk about the variations. So for example, we have something like Varun@clay.com or no reply@clay.com or v.anand@clay.com. You never know what format is that email gonna look like. Is it a business domain? Is it a free mail domain? Is it like something like a system, no reply, or a role like office ad or invoices ad or anything like that? Or, and I'm only gonna touch upon this briefly because there we go into the territory where it really only makes sense to build this when you know for whom you build it. So when you have email addresses like mark.miller2@apple.com, I haven't looked it up, but for sure there are more than one Mark Miller at Apple, at any large company. Or maybe the email address is just mark@clay.com. There might be 2 or 3 marks. So how far can you resolve that, right? What's the way to account for that? I'm going to talk about these things. So what needs to be understood? We basically have 2 pieces of three parts in an email. That is the local part. That's what's before the @ Andreas @ Varun @ and then there is the domain and the domain name and the top level domain. The domain name is, I believe it's the whole thing, clay.com, and the top level domain is .com. So what pieces of this are interesting to us? What's interesting to us is, of course, the domain itself, because that can give us the name of the company. And of course, what is in the local part might or might not tell us a lot or a little about who sent the email. Is it a system? Is it a role like office ad, no reply ad, or is it a person? And if it is a person, what type of information do we have in here? And the reason I'm so detailed on this, and I think I'm just going to jump over into Clay to show this, it all changes how you can approach resolving this with AI. And I'm going to show it in a second. So what I want to go back to before I jump into Clay, I want to show the 2 approaches that I'm gonna demonstrate first: the database lookup and the agent only lookup. Let's hop over to Clay. And what you see here, and this is not a professional course, right? So I'm gonna jump back and forth quite a bit in this, but bear with me. So what you see here, find professional profile, is a stand-in for the database lookup. I used LeadMagic here. LeadMagic has really good data, and you would also probably not use just one provider for that, but you can use a waterfall, use LeadMagic first, then use Snov or anything like that. But what I want to demonstrate is this basically goes in here, takes the person's work email that we have found and does this database lookup, right? Do we know this work email? And if so, what LinkedIn profile is associated with that? This is super simple. It can be quite effective. It varies, of course, from market segment to market segment. For some audiences, that's going to be a much better hit rate than for others. Let's say eyeballing this, you get maybe a 40-50% hit rate. When you combine providers, you get a higher hit rate, and that can already be good. This is where we are really talking here about like pushing this thing and learning and building. So that can already be the right thing. I would argue that if you do this, there is a business case for it. If you do this for any type of high volume inbound enrichment or anywhere where, like, in isolation, if something is 10 credits or 5 credits, okay, if something is working, that cost has to be marginal for the outcomes, right? But at some volume, it really does matter. When you can find a solution that does the same thing at higher accuracy for a tenth of the price, I think there can be a very good business case for it. So let's go to the other approach, which is really, this is a Claygent Argon, which with some changes that have happened under the hood in, I don't know, the last couple of months, I am seeing very good results with that. It's basically a very capable AI model that's used for Claygent, Clay's AI-powered web scraper. That's my word, not theirs. It's pretty good at understanding what you actually want to accomplish, taking many, many steps. I've seen up to 20 steps / websites visited. It really does a lot of crunch work in order to understand what you want to do and then executing on that. And what you see here is a very simple Claygent. Honestly, for this one, I don't even remember how I came together. I use meta prompting. I don't write prompts myself. I can show that a little bit. It's not the main thing I want to talk about today. But this is, in the end, a fairly simple version of a prompt. And the beauty is, for 3 credits a row, you get very good results. So actually, the input data, just for the context here, I built in order to combine things that I'm building. I built this many times for clients, and I always want to push what I learned to improve it. So this is kind of a really good version of that email to LinkedIn resolver. Anyways, the input data here is calendar bookings. So you see a few people twice for certain reasons because they registered with different emails. Anyway, so don't be thrown off by that. Overall, what this does is we take somebody's work email, throw that email into a relatively simple prompt. When you look at steps to perform, resolve this email address to a LinkedIn profile, pass the email address into local and domain part. This is what I talked about initially. This is what we get from emails. Then research the domain to identify the company. For me, this is where customization already comes in. Prioritize tag interpretation if it's ambiguous. This is why this is not a one-size-fits-all. If there is a Mike at something, then, this is about the domain. If something is ambiguous, then it will gravitate towards tag. Then decode the local parts using common patterns. That's actually more interesting to talk about. The domain should be a fairly simple resolution, but I'm going to get into that in more detail later. The interesting part is here, decode the local part using common patterns, name variations. I wouldn't even say this is necessarily exactly how I would want that Claygent to be structured, but here I don't want to die in beauty, right? The wonderful thing is that it's a simple prompt and it leads to already really good results. So this, in my book, is already a step up from a purely database-based lookup, especially when you see that it has a very high accuracy. For that, I would have to look at a much larger data set to be happy with this, and I would just not ship it like this, but test on many, many more rows and be more strict in verification. But overall, this is a really good result. So we have 2 things side by side. We have the lookup just going with email address, database, output of a LinkedIn URL, or we have a Claygent where we have this thing. When you look at it, here are the steps taken. So it visits this Clay blog, it visits this, it visits that. We find some stuff on Luma, it really pew, pew, pew. It goes out into the world and just does a lot of stuff in order to try to find Sia's LinkedIn profile here. And then it understands, okay, there's a Sia Verma at this company, but there's also Sia Verma at Clay. Clay is the company where the email address is coming from. So let's look for the LinkedIn profile of the Sia Verma who's at Clay. It does a lot of this, and you give away a little bit of the control when you use a prompt like this. But when the outcomes are right, honestly, it can be fine. It can be fine. But it's still 3 credits. And it Yeah, I would say that it can be thrown off probably quite easily with more edge cases and depending on market. Maybe not, maybe I don't do it justice. All I'm going to say is this is not, I believe, the best you can do. Interestingly, when you use the same prompt, this is, oh, actually, sorry about that. It's not the same prompt. It's already a better version of the prompt, but using a much, much cheaper model. So this is 3 Clay credits, depending on your plan. That's about 3 cents. More expensive if you have a lower end plan, but this use case is kind of pro plan and up, I would say. Otherwise, it doesn't make sense so much. When you look at the GPT Mini, we look at the cost of this is still quite cheap because it only is the mini version of GPT-5, but the accuracy and like what you're finding is not that great. I would say that less than 50%. So it's not really something I would rely on, but you can already see where this is going, right? You can go from the cheaper model. If it finds something cool, let's go to the higher end model where it's this part of the logic that I'm talking about. So instead of starting with 10 credits, where you sometimes find it or sometimes not. Of course, you're only charged when it's actually found, but you can take an approach where you use a cheaper model with a decent prompt in order to try to find it. Then you can bump it up to a higher end model. And only where this doesn't lead to a result, you can then do a database lookup. This is just like the overall approaches. What I, in the end, ended up doing, and this is a little bit coming from how AI works and how, especially when you optimize for low price and high accuracy, models have to be more focused. And here is the little problem. When you use a cheap model and you task it with this, have a look at this. This is, and I didn't write this prompt. I have a Claude project, which I'm going to show in a second, that produces these prompts for me. But the overall point is this is quite the elaborate prompt and it has to do a lot of work. So for example, and if I spell it out or not, it has to do the work. This is more bespoke, I would say. And there you go from, okay, address the local part using name, sufficiency, heuristic, whatever, like person, full name, first name, last name, or we have only the first name or only the last name or the initials. All I want to say is this Claygent has to do that resolution from what type of email address am I even seeing? Okay, now I understand this is the name, this is like the first name, this is like the last name, and then it can go out into the world and try to find that LinkedIn profile. This is where a more intelligent / expensive model will already have an easier time doing that. And you see it in the results it produces. And you see it in the results the cheaper model produces. It's not an apples to apples comparison because I used a different prompt here, but you get quite similar results even with like the same prompt in a cheaper model, probably a little bit worse. The point is, what then is an approach to do this is to really focus the agents. What that means is use really cheap agents, GPT-4o Mini, for example, but in a much more focused way. And that is what we are seeing here. So the first things I'm doing is to resolve the local part of the email, basically the part before the at, into what are we even seeing there. And the way I address this is, and this is, I wouldn't call it a trick, but it's something that I don't see used a ton. When you look into this, it's not a Claygent kind of, but it's this use AI integration in Clay. And in the top right, so first, this is what it looks like initially, right? Where you can type a little bit of the stuff that you want to do. I basically never do that. Probably I should. But anyways, when you go to configure, then you can say, instead of web research, where any AI model can have web access thanks to Claygent, you can say create or modify content. And what that does, it will only run on local data, meaning data you have right here in the table. That is a huge advantage because when I take as an input the email username, which is the local part, and I want to know is this the first name only? Is this the last name? Is it first name, last name? And what is the likely first name, last name? I don't need to do like a lot of like online search on that. I purely want to do that with the data that I have, because honestly, it's you know it when you see a thing. When we look at an email address, we understand in most cases if it is a first name, if it is a last name, or if it's a combination of these. And because that is so well documented, AI knows. So when you ask AI, is this a first name or is this a last name? Most of the time it will get it right. And this is what we see here. It's this email name extraction. It only looks at the email, and maybe I should show this in a second or in a second before. It's actually quite cool. This is how I use Clay a ton. So I just basically create the formula that gives me only the local part by saying extract everything before the at from, and then I just give it the email field. And what that does is it already focuses the data I'm putting into AI. I'm taking this, the email username, and I'm putting it into this prompt that has like the direction to say, is it examine the email local part? Is it a first name? Is it a last name? Is it the initials? And I'm going to show how I got to the prompt in a second. But that already outputs something pretty cool. So from this output, we get to, this is the pattern that is detected, likely first name, likely last name, and the likely full name. And that is just mapped out here. I just mapped out the likely full name. And that's what we get, right? When the email address is whatever, Sylvan@StackGenius, then we only have the first name. We don't have a last name. We only look at the data that we have. But this is already super clean. So we get from like the email address in itself to something that is an actual name where AI is already part of making this possible, right? So not in all cases, but in some cases, we get much cleaner and richer data than without AI. And the whole purpose of this is to actually feed into another AI only the first name, the last name, and the company name, because what you saw later on, the problem why, where is it? The problem why the cheaper AI model doesn't get so many results or such good results as the more expensive AI model is because it can't do all of these translation steps or action steps or logic steps, however you would want to call it. So in order to go from, this is the whole email address, understand what in this is the name or what in this is the local part, understand what of the local part is a first name, what is the last name, and then go out into the world and try to find the LinkedIn URL for that person. That is just such a tall order, and you will not get to good results with a cheap, low-end LLM model, what basically means they are not as smart and can't take as many steps. This is like an easy description of that. So let's go back to this. We are preparing the data now to be used for a lower-end model. And I'm just going to continue with that flow, and then I'm going to show how I get to these prompts that you see here. I didn't write it. I had it being written, and I iterated on that. But moving forward, we go from email to what is the likely name based on the data we see in the email. And then from here on, and this is where I'm really pushing it, you could really just take the domain and run it through Enrich company, and it's 1 credit, so it's already pretty cheap. And then you get basically the company name and all the LinkedIn enrichment data you want to have for a company, right? But here, I really only need the company name. And this is, in many instances, the company name is going to be the domain, but in many instances, it's also not going to be the name. So, for example, for apple.com, Apple is also the company name, but the company name might also be, the company name might be Frontier Talent, and the domain is bfrontier, and then the name is not bfrontier, right? It's super obvious. I'm just want to call it out. So what I'm doing here is use AI in order to get from extract the likely name of somebody. Oh, what I forgot to show. The cost of this would be Let's see if I can zoom it. This is a 10 cents. This is 1 cent. This is a tenth of a cent. And this is hundredth of a cent. So this is not even a tenth of a penny. You can absolutely run this at unlimited scale and it will not factor into data cost at extremely high accuracy. And then we have the likely name. And then I'm doing the same for the company name. So in this instance, and again, I'm using GPT-4o Mini. In this case, I'm doing it with a web search. And it's calling itself a company identity specialist who distinguishes between company names and product names. Okay, whatever. But the point is that otherwise, when you ask for a company name, you might get like just the main brand of what they are selling or something like that. So in the end, this is what worked in terms of accuracy. And the outputs here are what you see, for example, here. What example do I use? The output is, okay, this is the domain. Steps taken, it visits the website, and it fully understands that B2B Catalyst is the name of this company, or Delegate, or Clay, or whatever, right? So what we have now is the likely name and the company name, and this is then put into another GPT-4o Mini Claygent, so super, super cheap, and it has like instructions to go from name to LinkedIn URL. But the big difference is we can give it the likely first name, we can give it the likely last name, and we can give it the company name and the company domain. And this thinking work does not have to happen on the agent side anymore or on the AI side anymore, but we actually just give it the data. And what I want to point out here, the wonderful thing about being able to even reference the first name, the last name, all of these fields, I want to show where that comes from. That comes from using JSON prompting, specifically structured outputs, what you see here. All of this part in define outputs, so just going up here, you have the prompt. You have sometimes the system prompt. I think I scrolled over. This is the system prompt. At the top is the prompt. And then we have the JSON schema output field. And this is like the data that is produced by the prompt further up is put into this format. And what that does is it gives us the outputs like this, where we have the pattern, the likely full name, the likely last name. In these fields, I can reference here in the Claygent. It makes all the difference how to work with data in a go-to-market context, because you have like very granular access to all this data. Very important part. And here is the first result of what we are getting. So we have the email address, we identify the likely name, we identify the company name, and these are the results we are getting. We are already seeing results here. Let's look for whatever, my friend Jordan, like this. These results cost, and I want to show it again, a little over a tenth of a penny. This is effectively free. And it does it at such a high accuracy because of the way the Claygent is built that when you don't consider the time going into building, and this is why it must be the juice must be worth the squeeze, right? When you consider the time building, it might or might not be the right approach. But like when you say at scale, it's absolutely worth pulling time in the front in order to have much lower ongoing data cost later, then it can absolutely be worth it. And I'm using a little trick here, by the way. When you look here, there are some responses where we did get a LinkedIn URL. So here, for example, this person is Sylvan Schwartz, but it didn't output the domain. So you have two ways of doing this. You can instruct the Claygent not to output a domain if it's not quite certain of its results. But I believe, or that is a way that I'm using to build, you get this when you get Claygent output. You get the confidence, which can be low, medium, high, or very high, I believe. Maybe there's a very low, I'm not sure. But instead of just mapping this out, which would be hovering over the LinkedIn URL and then adding that as a column, I'm using a formula which just has one more step. I say if the confidence, and then I link into the Claygent, If the confidence is high or very high, then print, meaning output, the LinkedIn URL. Else, print nothing. What that does is it looks at, is it high? Is it very high in terms of confidence in the result? And only if it's high or very high, only then it will output the domain. In this instance, these are 100% correct. This is where you have to play with it in order to get it right. And the next thing is really conditional logic. So because we now have the agentic approach, I don't even know if you call that agentic, it's a Claygent. We have this approach where we build an AI thing that gets us to the point of maybe a little over half of people with high quality LinkedIn URLs, which is already cool, right? You basically saved half the ongoing data cost with this. But what we do from here is do the database lookup approach. So I usually run snorf first, which allows you to take in an email address and it will output somebody's LinkedIn URL. And that runs with a conditional formula. When you see here, only run if the Claygent intermediate result is empty. So if this column does not contain a LinkedIn URL, then we do the database lookup. And from here on, I would say it's a matter of preference, how you continue with this. This is a data set of maybe 25 inputs. And when you see there are 6 where neither the database lookup or the agentic lookup led to a result for one reason or the other, right? And then you just go in and use a very high, like a high-end model, in this case Argon, and you say, you know what, if we didn't find a result with the database lookup, and if the cheap AI didn't find a result yet, go wild, go out, try to find these people. And I found it was super interesting that, for example, for my friend Dave here, it actually even looked at, oh wow, like there is like, okay, let me search for D or Dave Goben, and oh, there is somebody like who wrote a book, and then okay, there's some Facebook, and you might introduce inaccuracy here. This is why it's important to confirm results and to build things in a bespoke way, because if you know your company or your client sell into a specific segment of the market, you can prime the Claygent in order to, if there is 2 D Gonovans, look for the one who is associated with tech. You might still get inaccuracies there. Of course, even a person purely based on the email would not exactly know who we are looking at, because I remember this was even just a Gmail address that we used as an input. So there's really only very few pieces of information in here. Remember the first thing that I showed. If it's a free mail address, you have so much less to go for. But still, you have a high chance of getting to a result. So there's the staggered approach of breaking down the data into the parts with like other methods of preparing the data for a cheap agent, a cheap AI to not have to think about it too much. Go out, try to find the LinkedIn URL. If we don't find it with that, database lookup. If we don't find it with that, higher end Claygent lookup, or you might use a waterfall of like different providers that can go from email address to LinkedIn URL. And I believe here I use the same method. So for example, if confidence is high or very high, then print the LinkedIn URL. Again, this is a tiny hack, but it prevents this where B steward, okay, that might be many different people, and we basically just, this allows us to not have too many, or in this case, no false positives in here. If you would just map it out, then you have many more false positives, but this way you can actually cut out the high and very high results. And then we have a merge column. I'm a big fan of merge columns. So what this basically does is like, of course, also staggered. I have multiple intermediate results here that combine the results of previous steps. So just to show it, the intermediate 2 looks at the result from the first Claygent and the result from the snorf lookup. So AI and database lookup if either of these got a high quality result, it's going to be in here. And then we have a third approach, which is the high-end AI model, and we get a few results, and then this merge column really just puts them together, intermediate 2 and the high confidence results of the last Claygent. And that I have implemented this a dozen times across different workspaces. And the quality of these resolutions is just incredible. And the cost of it is maybe a cent per result. I'm saying maybe because it's a mixed calculation. For some, it will be 3 credits. For some, it's less than 1 credit. Overall, because of the ratio that there are very few where we need to use the high-end model, overall, this is about a cent per LinkedIn URL. And from here on, you're really off to the races. Whatever you want to do with it, once you have the LinkedIn URL, you have all possibilities. Like I'm using this in this instance. Once I have the LinkedIn URL, I enrich the person, and then I have like this little 16-word summary. Who are they? What are they doing? Since when are they at the company? What are they talking about? And you can play around with that, right? This is like purely now I'm playing with it. But as you can imagine, once you have the LinkedIn URL, you're good to go with whatever you need for go-to-market. So far to that build. To recap, we use a formula to extract only the part before the @ sign. This gives us, just purely on a formula basis, Scott, Elliot, Robert, Sylvan, Sia, Verma, whatever. Then we extract the likely name from that already with AI, where we have AI look at the input data. We don't know how it looks like. We just know that it's going to be names, or I even built a little part that there's only names going in here. You can already use AI to decide if something is a name or a system or a role, and then you don't have to move forward with it. There's no point in trying to enrich office@clay.com because there won't be a LinkedIn profile because it's not a person, but that is not happening in this workflow. But then again, we have the likely name, we know the pattern, which I believe I didn't even use that, but think about it in a way that having AI produce high quality data, in this case, the context, is it a first name, is it the last name? You can use that data that is then already existing for another cheap AI model, because then it doesn't have to do 2 things, but it can take the input or the output of another model and use it as input for the new one. And in the end, you end up with like really high quality data pipelines. But because you're not asking a cheap model to do a lot, or you're asking an expensive model to do a lot, you can really get the best of both worlds at the cost of complexity and build time. Now we have the first name, last name. We put these into a Claygent. Then I run a Claygent that looks at the domain and does a resolution to the company name. Again, this is all tenths of a penny around that price, so it doesn't even add up to a penny in many instances. And that is put into a Claygent, first name, last name, company domain. Go out and find it. We extract the results where the Claygent comes back high or very high. And then we run an integration. In this case, I ran Snorf. And you could, after that, use a LeadMagic in order to try to increase coverage further. And then all these results are merged. And as a last resort, so to say, or the last level of escalation, you use a higher end Claygent in order to like really push for the best coverage you can get. And then you end up with this wonderful list of emails. What I would wonder if I was watching this is like, how the hell does this guy come up with these prompts? When you just look at the prompt here, for example, for the company name, it seems such a simple thing, but when you play with it and you say, hey, give me this company's name. Again, when you use an Argon, a more intelligent model, it will probably get really good results, but it's also going to be 3 credits per result. Here we look at a cost of, again, in the tenth of pennies. Really, this is a 2 orders of magnitude difference, and I would say that is usually worth it if you are looking at any type of volume. And now we have all of this data. but how do you get to this prompt? And what I'm always doing, you see this little I. What that basically means is I use my AI chats and I put the URL into the column description, because that allows me to always go back to the Claygent that built this prompt. Let's do this. I copied it. Let's go in here. And this is the chat that led me to this agent. I'm really just using Super Whisper to talk to AI, and then I'm saying, hey, build a natural language prompt for Claygent that has a simple task. The input will be a company domain, and the agent will have web access, and I want to know the company name. Be mindful that the Claygent will probably search for it, and if you search for a company name or a company domain where maybe the domain isn't found, or there is like another search result that scores higher for the domain, that happens especially in startup land, where you search for new startup 123 and there is a new startup 12, then it might actually say, oh, this is the name of the company, because it does a search for the domain. If something else ranks higher, again, that can happen in startup land, you might get the wrong name back. So you have to think about these things. And this is a matter of building the prompt, executing it, seeing what's wrong, and then going back into the prompt. And this is not a prompting session, so I won't like go into too much detail. But basically, at some point, I saw a mistake. So for example, one of the output was the first AI native management agency. That is a description of a company. That is not the company name. I needed to go back and call this out. Sometimes you can give AI exactly what it has done wrong. In this instance, I just said, hey, this is wrong. Be more mindful of this. And then it goes in and identifies what is the problem. And it goes back and changes the prompt and incorporates basically the changes that need to be made in order to resolve the error. And that usually goes back a couple of times. So for example, here, then I said, I don't want the legal name. I want the name people actually use. Inc. does not belong in it. The name is Frontier Talent. One result was Frontier Communications. Communications was just invented. This is bad. Don't do that. And like, I'm giving it, for example, here, the brand name credit flow was identified multiple times. But you also already said the company name is something different, so please output the company name. All of these things. This is like conversationally back and forth with the AI. And then in the end, I end up with a prompt that looks like this. This is the prompt that gives me the guidance of like how AI sees this task to be best accomplished. And it's absolutely fantastic for that. Don't prompt yourself. Tell AI what you want, and AI will build the better prompt. The important thing is to be really thoughtful and deliberate about what you are prompting for, and all the rules and guidance and constraints and the steps it should take. That is something where it's kind of a collaboration with AI in order to get to really high quality results. It's kind of an art and science in and of its own, so I only want to touch upon this on the surface. But this is how you build these prompts that you saw. What I am also using is always like additional project data. So this is a Claude project that I'm using for building Claygents, and it has like, how does the output of an enriched person in Clay look like? Enriched person, enriched company. So it understands what is the data it gets when it does a person enrichment. I also have like a deep dive on what Claygent actually does, how it operates, what is the logic, how should it be structured, what are its capabilities and limitations. And I also have like, what does Clay actually do? And additionally, what I'm adding into my Claygent builds is I'm dropping in a markup document, which is basically, this is how I want you to structure the prompt, how I want you to structure the output. And then I drop this document into what I just showed, URL, I think it was this. I drop that markup file in here because that can then instruct this prompt based on the structure in the markup file. Oh, okay, this is how I need to produce the prompt. So the user wants like the prompt to be itself already in JSON. It should contain the prompt itself. It should contain the output schema. This whole chat conversation has guidance, how I want the prompt in the end to look like, right? This is why it can do it so well and does it right nearly all the time. And I'm also like using variables that are not going to be replaced in the prompt, but I'm just saying use the variable throughout the prompt, and at the end of the prompt, give me all the variables that I used so I can slot in the actual variable, because what that allows you when you copy that over into Clay, let's just have a look here. What that allows you is when I need to make changes for this part, which always happens, I can just select this part, replace it, but I don't have to remap all the columns I want to put in here. It's a neat little thing. It makes life a little bit easier. Absolutely do it. And then I also copy the JSON output, which is the letter part of this chat conversation. And I also put this into JSON schema. And that gives me these beautiful, well-structured outputs that are very bespoke to what I want to do. And this I do really for all my prompts. I give them a lot of context. This is what I want to do. This is the data you're going to be looking at. This is how I want the data to look. And then I drop in my documented or my structure documents as a markup, and then it will produce the prompt in exactly the right format. In the end, what we are getting, and this is what you see here, let me go there again. In the end, we get LinkedIn URLs for about $0.01 per result, very, very high accuracy. It's a combination of AI, Clay, logic, conditional logic. How do I string things together? What do I make run conditionally, going from the cheapest to the most expensive usually? And that really unlocks so much, especially when you attack problems like this, where you think about how can I get to the result? Database lookup or AI web scraping. Database lookup, super simple, pretty expensive, not always a great hit rate. Web scraping, super cheap, harder to build, might be a little bit inaccurate. And when you combine all of these methodologies together, you get to some really beautiful outputs. Okay, that was a little bit of an excursus on, how did I call it, from email to LinkedIn, talking about how to attack the problem, understanding how to build, and how to get to this 95%. It's probably even a little bit more, but that also heavily depends on the market, that where basically the people live. If that is not on LinkedIn, it might be a little bit more challenging because maybe it hallucinates a few results. This is where it becomes important to have these safety nets of like only really outputting results where the AI has high or very high confidence. This is what we talked about. And then that it was a learning exercise, that I talked about logic, AI agents, the price complexity trade-off, and like what's the difference for this task between doing a database lookup and doing an agents build. Hope this was useful. Let me know what was unclear. Let me know how I can help. But overall, this is something I believe that can be quite helpful in many instances for go-to-market builds. Thanks for watching. See you next time. Peace out.